Computation of market equilibria by convex programming. We introduce convex programming techniques to compute market equilibria in general equilibrium models. We show that this approach provides an effective arsenal of tools for several restricted yet important classes of markets. We also point out its intrinsic limitations. Introduction. The market equilibrium problem consists of finding a set of prices and allocations of goods to economic agents such that each agent maximizes her utility, subject to her budget constraints, and the market clears. Since the 19th century, economists have introduced models that capture the notion of market equilibrium. In 1874, Walras published The Elements of Pure Economics, in which he describes a model for the state of an economic system in terms of demand and supply, and expresses the supply equal demand equilibrium conditions. Walras, 1954. In 1936, Wald gave the first proof of the existence of an equilibrium for the Walrasian system, albeit under severe restrictions. Wald, 1951. In 1954, Nobel laureates Arrow and Debrew proved the existence of an equilibrium under much milder assumptions. Arrow and Debrew, 1954. The market equilibrium problem can be stated as a fixed point problem, and indeed the proofs of existence of a market equilibrium are based on either Brouwer's or Kakutani's fixed point theorem, depending on the setting. See, for example, the beautiful monograph, Board 1985, for a friendly exposition of the main results in this vein. Under a capitalistic economic system, the prices and production of goods are interrelated so that the equilibrium price of one good may depend on all the different markets of goods that are available. Equilibrium models must therefore take into account a multitude of different markets of goods. This intrinsic large-scale nature of the problem calls for algorithmic investigations and shows the central role of computation. Starting from the 60s, the intimate connection between the notions of fixed point and market equilibrium was exploited for computational goals by Scarf and some co-authors, who employed path-following techniques to compute approximate equilibrium prices. Evis and Scarf, 1976. Hanson and Scarf, 1973. Scarf, 1967, 1982. In their simplest form, these methods are based upon a decomposition of the price simplex into a large number of small regions and on the use of information about the problem instance to construct a path that can be shown to terminate close to a fixed point. While the appropriate termination is guaranteed by the fixed point theorem, the worst case running time of these algorithms turns out to be exponential. Over the last few years, the problem of computing market equilibria has received significant attention within the theoretical computer science community. Inspired by Papadimitriou 2001 and starting with the work of Dane, Papadimitriou, and Safra 2003, theoretical computer scientists have developed polynomial time algorithms for several restricted versions of the market equilibrium problem. In this chapter, we focus on algorithms based on convex programming techniques. Elsewhere in this book, Verizzani 2007, algorithms of a combinatorial nature are presented.